Today we're going to be doing Module 5, Lesson 11, where we're going to continue working on finding the area of rectangles. But today we're going to be looking at mixed number by mixed number fraction side lengths. So instead of having a single whole number, we now have sides with two different fractions. We're still going to use the same strategies and skills where we're going to look at the distributive property and we're going to be using area models to help us figure out how to multiply these two fractions together. So we're going to start here with rectangle B. Rectangle B is kind of a warm-up. It should be similar to what we've already done. So it says rectangle B is 2 1/2 units long by 3/4 units wide. So the first thing we're going to do is draw that model out. So 2 1/2 units long. So I'm going to go 2 1/2. And then it's 3/4 units wide. So it looks relatively like this. And I split up the 2 1/2 from each other so that I can split this area model into two sections. Because then I can take the whole number section and the fraction section and treat them as separate areas. And I can figure out the area of this rectangle and then the area of this rectangle separately. So to figure that out, I can use my area model. We'll do this in two ways. We'll do the area model way first, and then we'll use distributive property second. So to figure out this first section here, this blue section, I need to multiply the 2 by the 3/4. So it's going to be 2 times 3/4. And this will give me what the area is of this first blue section. 2 times 3/4 is going to give me 6/4, because really that's a 2 over 1. And when you multiply fractions, you just multiply straight across. So the area of this first section here is 6/4, which I can simplify because it is a fraction greater than 1. And I can simplify it to 1 and 2/4, but we'll look at that in a minute. My next area right here, to figure this out, it's again going to be 3/4 times 1/2. 3/4 times 1/2, if I multiply straight across, gives me 3/8. So when I think of this as 1 and 2/4, we're going to add it together with the 3/8 to figure out my total area. Now, 4ths and 8ths are different denominators, but I can turn 4ths into 8ths by timesing it 2 by 2. So I can make this 1 and 4/8 plus 3/8, which gives me 1 and 7/8 square units. So this is the way we call the area method. Now, the equation that we just did, and looking at the dimensions, we did 2 1/2 times 3/4. We drew it out, we did the model, which is great, but we can also think that we can use the distributive property here to multiply this together. The distributive property is where you distribute your numbers together and you multiply them to all the numbers. So you take this 2 and you multiply it by 3/4. And you take this 1/2 and you multiply it by 3/4. Every number should be multiplied by all the numbers. We're distributing the 3/4 to the 2. We're distributing the 3/4 to the 1/2. So the first equation becomes 2 times 3/4. And then the second equation becomes 1/2 times 3/4. Now, notice that these are the exact same equations as we did over here in the area model. So you're doing the same multiplication. The area model way, we just drew it into pictures to show us why we were multiplying those. And why does it make sense that there's two equations? And it makes sense that there's two equations because it's the 2 1/2. The 2 1/2 each need to be multiplied by that 3/4. So when you multiply this together, you would have gotten the same answer of what? And 7/8 units squared. Let's try another one. This one now is a mixed number times a mixed number. So 3 1/3 units long times 2 1/2 units wide. So when I draw this out, 3 1/3 long, 2 1/2 wide. So 2 1/2. And just like we did before, we're going to split them into a whole number and a fraction. And then we're going to give them their own separate sections. So now this equation, there are 4 partial products that we're going to come up with. And that's because each one has 2 pieces. There's 3, there's 1/3, and we're timesing that by 2 1/2. So when we're looking at this, we're having 4 separate equations to find the area. So this first section up here is going to be 2 times 3. Because I'm just going from the column and the row. My second one over here is going to be 1/3 times 2. My bottom left is 1/2 times 3. And my bottom right is 1/2 times 1/3. So I have 4 equations that I will do separately to then figure out my 4 partial products to add them together. If I was doing this with the distributive method, my equation is 3 1/3 times 2 1/2. So I'm going to say, okay, I've got a 3, and I'm going to multiply this 3 by a 2. I'm also going to multiply this 3 by a 1/2. So I need to have 3 times 2 plus 3 times 1/2. Do you see these 2 equations in our area model? Wait, no, that's the wrong one. There's the 3 times 2, and here's my 3 times 1/2. Now, I need to take this 1/3, and I need to multiply it by its friends. So I can do 1/3 times 2, and 1/3 times 1/2. Oh, and I'm out of space. And those are these 2 equations. So you can see that both strategies here help us break apart our fractions into the 4 smaller, more manageable equations that we then can find our partial products and add them together. From here, we're going to have the same answers. We're going to have the same steps. It's just if we're drawing it visually in a model or if we're jumping right to the equation. I'm going to kind of finish on the area model side, I think, because I have more space. 2 times 3 gives me 6. 1/3 times 2 is going to give me 2/3. 1/2 times 3 is going to give me 3/2. And 1/2 times 1/3 is going to give me 1/6. Those are the exact same things you would get over here. They just might be in a different order. But you're going to get 6 plus 2/3 plus 3/2 plus 1/6. Now, when you add all these together, you might see that you have 3 different fractions here, and we have to find a common denominator. You have the option of either doing it 2 at a time, so you could just do like the 3 and the 2, or you can look at all 3 of your fractions and look to see, is there a common denominator that both 3, 2, and 6 goes into? And you can technically times them all together, so 3 times 2 times 6. Or you can say, okay, well, 6 is my biggest denominator. 2 can be turned into a 6, and 3 can be turned into a 6. So I'm going to turn all of my fractions into sixths. So 3 times 2 will give me 6. 2 times 3 will give me 6. So my new equation is going to be 6 plus 4/6 plus 9/6 plus 1/6. So my 6 wholes stay the same, and my fractions, 1 plus 9 is 10, plus 4 is 14/6. Well, 14/6 is a fraction greater than 1, so I can do 14 divided by 6. I'll be able to take, so if it's like this, I for sure can take 2 wholes out, and then I get 2/6. which can be 2 1/3. So add that to my 6, and I get 8 1/3 square units. We're going to do one more. Rectangle D is 3.5 units long times 2 1/4 units wide. So let's draw that out. 3 1/2 times 2 1/4. So we're going to have 4 different equations here. We're going to have 2 times 3. We're going to have 2 times 1/2. We're going to have 1/4 times 3. And we're going to have 1/4 times 1/2. Let's check that here with the distributive property. 3 times 2. 3 times 1/4. And I do like to draw the little rainbows. 1/2 times 2. Drawing the rainbows helps me make sure I've hit every number. 1/2 times 1/4. Okay, so we've got all of the equations here. So let's solve. 3 times 2 is 6. 3 times 1/4 is 3/4. 1/2 times 2 is 1, because it's 2 over 2. And then my last one is 1/2 times 1/4, which is 1/8. So right away, I can use the commutative property and move these around because they're all addition. And I can add my 6 plus 1 is 7. So now I have 7 plus 3/8, or 3/4 plus 1/8. I can see that a 4 can turn into an 8. And so I can times this by 2. So I can rewrite this as 6/8. So that's 7 plus 7/8, which equals 7 7/8 square units. So multiplying two mixed numbers together is pretty formula based. We're using the distributive property, or we're using the area model to show that we are doing 4 separate equations. If we have a mixed number times a mixed number, when we did a mixed number times a single fraction, we only had 2 equations. So it depends on what you're multiplying by, how much math you need to do to find the area of your rectangles.